Over the next few minutes, we're going to look at how we can bring a spatial context to some of the interactive tools available on RAND's website, namely this critical care surge response tool. Now, if you're familiar with this tool, you'll know that users can input different values for the number of critical care doctors, nurses, respiratory therapists, ventilators, and even beds at a given facility, along with other metrics. This tool then identifies the total number of patients who can be cared for per given shift, as well as the factor that is limiting the total number of patients that can be cared for. In this example, we see that it is critical care nurses. Now, this is a very valuable tool, but what if we wanted to understand these results among multiple facilities or at a county or state level? We could then use that aggregated information to make regional decisions and policy recommendations that increase these values and remove bottlenecks. This is where ArcGIS comes into play. In this dynamic and configurable application, I'm taking sample outputs from the previous tool and visualizing it on a map. Simple tools in ArcGIS allow me to even color code the facilities based upon multiple variables. In this map, the size of the facility relates to the total number of beds. Meanwhile, the color relates to the limiting factor at each facility. For example, in this sample dataset, I can see that Kirkland Hospital is a moderately sized facility that is limited by the number of critical care doctors. In the dynamic chart, I can also see that the number of critical care nurses and respiratory therapists are a limiting factor as well. I can even see spatial trends in my dataset. So, for example, here in central Washington, I see that the predominant limiting factor appears to be the number of critical care doctors. This could inform broad stroke hiring decisions that might encourage the onboarding of additional doctors in this region. Meanwhile, near Seattle, I see that there is no single factor responsible for the bottleneck. A push for hiring more critical care doctors in this region might not be highly effective. But using the information in this application, we can see a path forward to spatially balancing resources, where one facility has a surplus that could alleviate the bottleneck at a nearby facility. This would increase the total number of patients who can be cared for in a region just by shifting resources. I should also mention that this application is dynamic, meaning that as values are updated behind the scenes via web forms or data loading processes, this map and the charts and the graphics, it all can be refreshed automatically. Now, this is important in other apps where real-time information is necessary, like this configurable scenario planner tool. Using a data feed published by HHS and ArcGIS Online, I can visualize information from the Community Profile Report on HHS Protect. This dataset contains several key indicators of COVID-19 transmission and hospitalization. This map is currently showing the number of confirmed COVID-19 admissions per 100 inpatient beds in the last 7 days. And I can see which counties are experiencing the highest number of admissions highlighted in red. ArcGIS allows users not just to visualize this information, but analyze it. For example, I can select a county with a high number of admissions and view a summary report of the facilities in this area and the resources available. I can even add additional neighboring counties to this analysis to make plans for resource allocation and gain regional situational awareness. This COVID-19 dataset is just one of the dozens of regularly updated and live data feeds available to ArcGIS users, including up-to-date satellite imagery, natural disaster alerts, and even traffic. Of course, the best time to make these plans is before an emergency occurs. With that, ArcGIS allows you to test an unlimited number of scenarios in a collaborative environment to be at the forefront of public health preparedness.